Dear students, hope you are great. Today we are going to take chapter 6, Introduction to the Atoms. Let's start. The beginning of atomic theory. So we should know the beginning of atomic theory. Imagine that you cut something in half, then you cut each half in half and continue doing so. Could you keep cutting the piece in half forever? Around 440 BCE, Greek philosopher named Democritus, scientist Democritus, so that that you would eventually end up with a particle that could not be cut. This particle is called what? This particle called an atom. So this scientist showed that you could end up with particle that could not be cut. This particle is called what? An atom. What's meant by an atom? An atom, word atom mean what? Mean not able to be divided. So which is mean none, tom, which is mean divided or divisible. So atom mean not able to be divided. What's meant by an atom? An atom is the smallest particle in which an element can be divided and still have the properties of that element. Dalton atomic theory based on experience. Dalton atomic theory. By late 1700, scientists had learned that elements combine in a certain proportion based on mass to form compounds. Like what? Like when hydrogen, it's an element, hydrogen atom, react with oxygen to form what? To form water compound, H2O. So hydrogen is an element and oxygen is an element combined together to form what? To form water compounds in a certain ratio, as we have here 2 hydrogen and 1 oxygen. So the ratio here 2 to 1. So scientist Dalton learned that an element combined like hydrogen and oxygen combine in a certain proportions, in a certain ratio to form what? To form a compound. For example, hydrogen and oxygen always combine in the same proportion or same ratio to form what? Water. Dalton, British chemist and teacher, wanted to know why he experimented with a different substance. His results suggest that elements combine in a certain proportion because they are made of atoms. Dalton theory state the following ideas. So Dalton theory state what? State the following ideas. First one said that all substances are made of atoms. Atoms are small particles that cannot be created, divided, or destroyed. So first one who discovered the atom was Democritus. Then Dalton said that all substance or all matter are made of atom. These atoms are small particles that cannot be divided, cannot be destroyed or created. As for example, carbon atom. Look, this is a carbon. Let's imagine this is a carbon atom. We cannot destroy or divided this atom because it's the smallest particle. It's the smallest particle in carbon element. Smallest particle. Atom of the same second idea. Atom of the same element are exactly alike. Atom of different elements are different. For example, carbon. We have atom of carbon. Let's imagine this is an atom of carbon, and oxygen. This is atom of oxygen. So atom of carbon and oxygen are different. because there is different two elements. So atom of a different element are different in properties, different in mass, different in weight, and so on. So Dalton said that an atom of the same element are alike, atom of a different element are different, like a carbon with oxygen, because it's two different elements. So the properties of the atom of carbon are different from properties of atom of oxygen. Atom join with other atoms to make a new substance, as for example carbon plus oxygen form carbon dioxide. So atom of carbon react with atom of oxygen to form what? To form a carbon dioxide in a certain ratio, to make a new substance, to make carbon dioxide. Thomson discovered of the electrons. So Thomson discovered what? Discovered electrons. British scientist named Thomson showed that Dalton's theory was not quite right. Thomson discovered that there are small particles, which is called electron, present inside the atom. Atom can be divided into even smaller parts. Thomson experimented with a cathode ray tube. He discovered that a positive charge plate attracted the beam cathode ray and made it bend down. Thomson concluded that the beam must be made of particles that have a negative electric charge. This negative electric charge is called an electron. The negative charge particles that Thomson discovered are known as electrons. Look at this experiment. Thomson got a cathode ray tube. This tube called cathode ray tube. This tube get a cathode ray tube, which is a vacuum. So pump out all air inside it. Pump out air. Vacuum. And pass a cathode ray. Put here a cathode ray. By applying electricity, so here is electricity, negative pole and positive pole. He showed that this cathode ray passes in a straight line. This gas passes in a straight line from the negative cathode to the positive anode. So he showed that this gas or the waves or the beam move from a negative pole to the positive pole by applying electricity. Then add here a magnet. In a magnet we have a negative pole and positive pole. Negative pole and positive pole of magnet. After add a magnet, he showed that the beam deflected. This beam deflected toward the positive pole. This means what? This means that a cathode ray made of negative charge, as when attracted by magnet, it's formed from. So the cathode ray formed from negative charge to attract by magnet. Look. He discovered that a positive charge plate or positive pole in the magnet attract the beam, attract the ray of cathode ray, and made it bend down, made like this, deflect like this. This means what? This conclude what? So Thomson conclude that the beam must made of particles they have a negative charge. This means that this beam made of negative charge to attract by a positive pole of magnet. So beam must be made of particles that have a negative charge. This negative charge called what? Called electrons. Because opposite charge attract. The negative charge particles that Thomson discovered are known as electrons. Thomson showed that electrons are a part of atoms, but his experiment did not provide a way of knowing where electrons were located in atoms. So he showed or concluded that an atom made inside the atom there is a negative charge, which is called electron, but he didn't know where the electron located in the atom. He didn't know what? He didn't know where the electrons located in the atom. So made a guess that electrons were mixed throughout an atom. He imagined that an atom is a positive charge, embedded in it a negative charge, like this model called Plum's modeling model. Plum modeling model, like ice cream, like chocolate chips ice cream. He imagined that ice cream or white inside the ice cream, white, this is an atom, and the chocolate chips is a negative electron embedded in ice cream. So Thomson model, chocolate chip, ice cream. Chocolate chips represent electrons, ice cream represents the rest of that. Rutherford Atomic Charting Gallery. He designed an experiment to study the parts of atom. Rutherford wanted to study the parts of the atom. By passing a beam of small positive charged particles, which is called alpha particle, at a thin sheet of gold foil, Rutherford get alpha particles put here. This is a radioactive source that emits alpha particles. Alpha particles contain a positive charge. Alpha particles contain what? Positive charge. Alpha particle, which is a positive charged particles, alpha particles. So he get a radioactive source that emits alpha particle, which is made of positive charge, to the gold foil. Rutherford put a special coating behind the foil. The coating glowed when hit by positive charge particles. Rutherford could then see where the particles went after hitting the gold. He expected the particles to pass right through the gold in a straight line. Most of the particles did just that, but to the Rutherford's great surprise, a few particles were deflected, some even bounced straight back. So after emit a wave, he saw that the particles pass through the gold foil in a straight line like this. Most alpha particles travel through the foil undeflected, in a straight line, undeflected. This means what? This means that the atom is mostly empty space. Let's imagine this is a gold foil. This is made of an atom. Look, this is atoms. Made of atom. This atom of foil. By passing alpha particle, look, let's imagine this alpha particle. When it passes or travel through the foil, this means what? This means that this atom is an empty space. There is a hole here that pass the alpha particles. While if I emit alpha particles through in a dense or plugged atom, what happened? It will turn it back. But some of the alpha particle pass through the atom, or inside the gold foil, pass through the atom. This means what? This means that the atom is mostly empty space. The atom contain empty space to pass the ray, to pass alpha particles. But he's surprised. He see that some alpha particles are deflected like this, deflected by small angle. This means what? Atom. Inside the atom, there is a nucleus containing positive charge. If the alpha particle made of positive charge, right? If the positive charge hit the positive inside the nucleus, what happened? When positive hit positive, what happened? There is a repulsion, right? So when alpha particle hit the positive particle inside the nucleus, what happened? It will repulse like this, deflect. It will deflect like this, because positive and positive repulsion. So when two positive particles like alpha particle and positive inside the nucleus hit together, what happened? It will deflect. This means what? It means that the nucleus is positive charge as is the alpha particles. But occasionally some of the alpha particles travel back from the foil. Some bounce straight back. Some alpha particles travel backward. This means what? When the alpha particle, let's imagine this is a nucleus, this is an atom, contain nucleus. Inside the nucleus there is a positive charge, and the rest of the atom like this, the rest of the nucleus like this. So when the alpha particles hit this space, what happens? It will travel back. When alpha particle hit the dense nucleus, what happens? It will travel backward. So the nucleus carry most of the atom mass. When the alpha particles hit the nucleus, what happens? It will travel backward. While if the alpha particle hit the positive pole or the positive charge inside the nucleus, what happens? It will deflect. So let's imagine this is an atom contain nucleus. Inside the nucleus there is a positive charge. When the alpha particles hit that positive charge, it will deflect like this. While if it hit this space, what happens? It travels through the foil or the atom. If the alpha particle hit this space or this atom nucleus, what happens? It will travel backward. That's it. Thanks for watching.